Hello, my name is Martin Reyes, and today we're going to be looking at battery electric vehicles versus fuel cell electric vehicles. So my topic here is going to be split up into 6 sections, starting with an introduction, the relevant criteria, and a conclusion. So starting off our subject, we know that gasoline vehicles dominate the current automobile market in the United States, but they unfortunately emit a lot of harmful gases and toxins into the environment. So they're knowing that there is great public and commercial interest in trying to mitigate that environmental detriment. It is worth looking into what types of actions that we can take that are feasible. So in September 23rd of 2020, California's Governor Gavin Newsom signed an executive order banning the sale of gasoline-powered vehicles by 2035. Considering that California is the most populated state in the United States, this mandate would significantly benefit their air quality and total carbon emissions. So there's going to be two different types of electric vehicles that we're going to be looking at for this report. First of all, we're going to have the battery electric vehicle, which uses a large traction battery pack to power the vehicle's electric motor. The amount of available energy on board is actually indicative of the size of their batteries. The second vehicle we're going to be looking at is the fuel cell hydrogen vehicle, which also uses electricity to power their electric motor. However, electricity is actually produced in the car itself using hydrogen gas as a fuel. So we are going to be looking at a gasoline alternative vehicle that a California consumer in 2035 would consider purchasing. So the first set of criteria that we're going to look at is availability and cost. And here we have two different graphs, one for BEVs, one for FCEVs, and we can see that on average the price of a BEV tends to be a little bit lower than a FCEV. And another thing that we can look at here is just the availability of these vehicles. So even though this is a relatively small list compared to gasoline vehicles on the market, we only have 3 FCEV models that are currently available for retail. So that is a concerning number, but other automobile manufacturers are looking into pumping out more models in this category. So something else also to consider is beyond the initial purchase of the car, the national and state governments offer incentives to help consumers buy gasoline alternative vehicles. So for battery electric vehicles, we have a standard rebate of about $2,000. It goes up to $4,500 for a fuel cell hydrogen vehicle, and there's other many benefits that consumers can utilize from the state and national governments. So the next criteria that we're going to be looking at is going to be range and battery. And range is the amount of mileage that you can get per charge, and the battery is indicative of, again, that onboard power and energy source. So when we looked at these tables earlier, we actually have a calculation for range, and we can see here that in miles, FCEVs often fare about 89-ish miles better than the standard BEV. So they're a lot more economical in getting the most mileage out of a charge. We also see here that this calculation of energy density, which is watt hours per liter, is indicative of the kind of performance that you have for a smaller and smaller volume necessary for power. So what we do see here is that hydrogen vehicles have a larger energy density, meaning that they can pack more energy into smaller spaces than you would have for a BEV. And this is actually indicated in this graph right here, where we can see that there's that less amount of energy storage volume needed for more performance in range for the fuel cell rather than some of these battery alternatives. So our next criteria that we're going to be looking at is fueling and recharging. Something concerning is that for hydrogen vehicles, there are only about 43 stations in the entire state of California for recharging, whereas you have 6,800 for electric vehicles. And we can actually see this qualitatively here by the amount of refueling stations for electric and hydrogen vehicles. Something else also to consider is the amount of time to recharge these vehicles. So we can see here that a hydrogen vehicle takes about 3 to 5 minutes to fully recharge, akin to what you'd see in a gasoline vehicle. whereas electric vehicles on a regular wattage power source, you'd have about 17 to 25 hours, and for a high performance power source, you'd have 4 to 5 hours. So it'd be very detrimental for somebody to forget to charge their vehicle, let's say overnight. The next up here that we're going to be looking at is our final criteria, but definitely our most important criteria, as is the entire purpose of switching to gasoline alternative vehicles, that being environmental friendliness. So first up here we have fuel cell vehicles, and something very important to recognize here is that the byproducts and products in general of fuel cell hydrogen vehicles are actually heat, electricity, and water, and neither of which are extremely detrimental to the environment. Also, several reports have shown that the methods of producing the materials for FCEVs are highly unlikely to toxify the environment. Whereas compared to BEVs, which, remember, we talked about how they rely on other energy sources to obtain their power. This is an important differentiation because about 62.6% of energy generated in the United States actually comes from non-renewable energy sources such as coal, such as natural gas, petroleum, fossil fuels. So this fact becomes further problematic considering that about 85% of electric vehicle recharging happens in American households overnight, usually taking up about 4 times as much as the standard household would use in electricity. And we can also see here a graph from the Environmental Energy Agency, which states that if a country exceeds 599 grams of carbon dioxide per kilowatt, they consider electric vehicles to be net climate change contributors to the country. So even though the United States hasn't exactly reached this number as of 2013, other states where electric vehicles are more populated, such as China and Japan, have well surpassed this, meaning that their electric vehicles are climate change contributors. And we also see here one last graph that shows that fuel cell hydrogen vehicles fare much better to the environment than you would have for some of these battery electric vehicles. And this is important because they can actually send out toxins into the environment, such as fine particulates, sulfur oxides, and even black carbon. And one other important fact to consider is that the mining of the resources, such as metals that would be used in battery electric vehicles on their batteries, is actually detrimental to the environment and is problematic for the air quality. So considering all of the criteria that we have gone over within the last few minutes, although electric vehicles are more prevalently available, the infrastructure is greater and more set up, and you have a lot more availability in models, we see that the hydrogen vehicle actually has a great amount of benefits in terms of performance, in terms of mileage, and also for the environment. They are definitely superior. So we would recommend a hydrogen vehicle for a California consumer in 2035. Thank you.